Okay, so far I worked through the first two steps, which is identify A is 4, B is root 3, C is 3, because A is the x squared, B is the xy, and C is the y squared. And then the cotangent of 2 theta would be A minus C over B. I'm not going to give you that, so you want to memorize that. You get 4 minus 3 over root 3, which is 1 over root 3. And then we know our tangent's better than our cotangent, so we flipped it. Tangent of 2 theta would be the flip of 1 over root 3, which is root 3. And again, how comfortable you are with your unit circle is going to help you. You know that root 3 would be at pi over 3. And then I'd have to divide both sides by 2 or multiply by a half. And I get theta is pi over 6. So you will get some credit for getting just to that point. Obviously not full credit because there's a lot of work left. But that is going to be a checkpoint. And then the point at pi over 6 is root 3 over 2 and 1/2. So I'm going to use that to find the x and the y. The x and y equations I will give you. So these are given to you on your test. X would be x prime times the cosine of pi over 6, which is root 3 over 2. And then minus y prime times the sine at theta, which is 1/2. And then I just put that into one fraction together, root 3 x prime minus y prime over 2. And then I did it for the y. So x prime times the sine of pi over 6 is 1/2 plus y times the cosine at pi over 6, which is root 3 over 2. And I get x prime plus root 3 y prime over 2. That's the second checkpoint. So you'll get credit for getting to there. We're good on that, right? Yeah. Okay. So now I've got to plug it back in. So into my 4x squared goes 4 root 3. I'm going to drop off the primes, but then bring them back in at the end. You can do the same. It's one less thing you have to write out every time. Root 3, the x, which is root 3x minus y over 2 times y, which is x minus root 3y over 2 plus 3y squared. Y was x plus root 3y over 2 minus 10 equals 0. And then I'm going to expand this out. So the first thing I'm going to do is take care of my squareds. And we said yesterday that we could use the shortcuts for any binomial squared. So this is going to be 4. The shortcut is to square the first term. So the square of the square root of 3x is 3x squared. Square the last term. Negative y squared is y squared. And then 2 times the product of them, which would be 2 root 3xy. We said that was a positive x squared, or y squared, over 2 squared, which is 4. And then I go to the next term. If it was the difference 2 squared, then I could FOIL that out and cancel it out, but this time it's not. So then I would FOIL out the second set, so this root 3 is going to stay where it is, but I multiply these out. Root 3 times x is root 3x squared. Outer root 3 times root 3, or negative root 3 would be a negative 3xy. Inner negative xy. Actually, let me keep the color. And outer negative times the negative is a positive root 3y squared. And all of that goes over 4. And then I go to the last one. This should have been squared. Use that shortcut again. 3, square the first term, x squared. Square the last term, 3y squared. And then 2 times the product over 4. Minus 10 equals 0. Now I'm going to distribute, actually I'm going to get rid of my denominators. Everything there has a 4, which means I can multiply everything except for that 10 has a 4. Everything by 4, and I lose the denominators. So I'd get 4, 3x squared minus 2 root 3xy plus y squared plus root 3 times, this one I'm actually going to combine. This should be plus. So that changes. This should be a positive, negative. This should be a negative. So I get root 3x squared plus 2xy minus root 3y squared. Plus 3 times x squared plus 2 root 3xy plus 3y squared equal, or minus 40 equals 0. So that 4 is going to get multiplied by the constant as well. Now I'm going to distribute in each of the terms on the front. So the first one should be 12x squared minus 8 root 3 xy plus 4y squared plus root 3 times 3, which is root 3, which is 3x squared plus 2 root 3xy minus root 3 times root 3, which is 3y squared. Then I do the last one, plus 3x squared plus 6 root 3xy plus 9y squared minus 40 equals 0. Questions so far? So at this point, this next step, the whole goal was to cancel out your xy coordinate, okay, or xy term. If you don't, then you know you did something wrong, and hopefully you can check it from here. You don't want to continue with an xy term. The whole goal is to get rid of it on the rotation of the conics. So I'm going to do negative 8 root 3 plus 2 root 3, which is negative 6 root 3 plus 6 root 3, and these are gone. So at least I know I did that part correctly. Now I want to combine together what's left. So my x term, I've got 12x squared plus 3x squared, which is 15x squared plus 3x squared, which is 18x squared. The y, I've got 4y squared minus 3y squared, so that's y squared plus 9 squared, which is plus 10y squared. I'm going to bump the 40 to the other side, equals 40. I need to get this in standard form, so I'm going to divide everything by 40. I'd get 18, and I'm going to bring back my primes, okay, because they are part of my answer. This reduces to 9 over 20. So already you should be able to tell me what. So this is the standard form. This is the third checkpoint. You're going to give me that question. I mean that part as part of your answer. If there's a plus in between two squared terms, what kind of a ellipse? It's an ellipse. Most likely at this point you're going to have an ellipse or a hyperbola. Okay, what can you tell me about the center of the ellipse? 0, 0. Before I figure out A and B, I have to move this 9 to the bottom. So if you think about it, we've done this in the reverse, where if it was 20 over 9 in the bottom, we flipped it, and the 9 went to the top. We're doing the reverse. So we're just bringing the 9 to the bottom of the 20. So this would be x prime squared over 20 over 9 plus y prime squared over 4 equals 1. So what's bigger, 20 over 9 or 4? 4, which means a squared is 4. A is 2. B squared is 20 over 9. And B is the square root of 20 over 3, or 2 root 5 over 3. And because the A is underneath the y squared term, tells you what kind of ellipse is this? Vertical. So when I go to graph it, I'm going to have to approximate this. This 2 root 5 over 3, you can approximate it any way you want to. I can come back up to the top and say 20 over 9 is a little bit bigger than 2. And the square root of 2 is like 1.3. So I can approximate this like 1.3, 1.5, something like this. Or you can approximate it down here at the bottom. It doesn't matter where you do it. I could say root 5 is the same thing as like 2.2. 2 times 2.2 is like 4.4. 4.4 divided by 3 is 1 point. Like that. You can approximate it, okay? So now I got to graph it. But not on my regular axis, right? On my rotated axis. So what is theta? Pi over 6, which means I have to rotate this up to pi over 6. This is now my x prime. So I extend it out, draw a line that's perpendicular, rotate it if you need to. So if I rotate this around, and plot your ellipse. So the center's at 0, 0. We said it's vertical, so we're going up and down 2, and right and left 1.3-ish. And there would be my rotated conic. Questions? So, yeah.
You would multiply the 9 times the 1 to get 9 to find out if it was an ellipse, right?
You mean from the beginning? So as soon as I divide by, what did I have to divide by, 40, and I simplify that, that's when I know what it is. As soon as the one's on the right-hand side. Because they're both positive and they're both squared, I know it's an ellipse. Julian? Yeah, I'm going to. So on the homework, thank you. On the homework, there was one in which I had to complete the square. I'm going to work it through on the video, okay? You don't have to, you're not going to complete the square on these on your homework. On your test. However, obviously, there's complete the square, so you want to make sure you can do it. It's just that it will take you like a half hour to do one problem if I did that. Okay, this is similar to like one of the ones in the homework. I think almost everybody had this question, but if not, something similar to this. So the first thing I'm going to do, again, identify A, B, and C, which A, there's no x squared, so A is 0. B is what's in front of the xy, that's 1. And C, nothing, no y squared, so that's also 0. So the cotangent 2 theta equals A minus C over B, which should be 0 over 1. I'm looking for where the tangent, so I flip it, of 2 theta, is 1 over 0 or undefined. So we know this to happen at pi over 2. So 2 theta equals pi over 2. Theta is pi over 4. So that's the first checkpoint. And then x equals x prime times the cosine of pi over 4 minus y prime times the sine at pi over 4. Y equals x prime times the sine of pi over 4 plus y prime times the cosine of pi over 4. So pi over 4's coordinate is root 2 over 2 and root 2 over 2. So I get x. I'm going to lose the prime but bring it back at the end. So x times root 2 over 2 minus y times root 2 over 2, which is root 2x minus root 2y all over 2. Y equals x. Again, I'm going to lose the prime but bring it back. Root 2 over 2 plus y root 2 over 2, which is root 2x plus root 2y over 2. This is the second checkpoint, so you'll get points for your x and your y. Now, I need to take those and plug them back into my initial equation. So the x, which is root 2x minus root 2y over 2, gets multiplied by the y, which is root 2x plus root 2y over 2, plus x, which is root 2x minus root 2y over 2, minus 2 times y, root 2x plus root 2y over 2, plus 6 equals 0. So now I'm going to multiply these out, distribute the 2, whatever you need to do here. These two are both the same. They're opposite, same exact terms, but one's positive, one's negative, which means I can use the shortcut of a squared minus b squared to simplify that multiplication. So the square of the square root of 2x would be 2x squared. The square of the square root of 2y would be 2y squared, and then I put a minus between them. 2 times 2 in the bottom is 4. Plus root 2x minus root 2y over 2. And then this one, these actually cancel out. Actually, but I'm going to keep it because I'm going to multiply by 2 to get rid of it in a minute. So I'm just going to distribute that 2 in. So negative, this negative goes to both. So negative 2 root 2x minus 2 root 2y over 2 plus 6 equals 0. So I want to get rid of the denominator. I'm going to multiply everything by 4. So this cancels. this would get multiplied by 2, this would get multiplied by 2, and this would get multiplied by 4. So I have 2x squared minus 2y squared plus 2 root 2x minus 2 root 2y minus 4 root 2x minus 4 root 2y plus 24. Now I want to combine my like terms. So I would first check for my xy term, and I don't have any this time. So I'm just going to group together the x squared. There's only 1, 2x squared, and then the x's, which would be negative 2 root 2x, and then group together the y's, negative 2y squared, and the y squared, and then the y to the first, negative 6 root 2y equals negative 24 gets bumped to the other side. Now I can actually divide all these by 2 and make it a little bit easier on this next step, because I'm gonna have to complete the square for here and for here. So before I do that, I'm gonna divide by 2, x squared minus root 2x minus y squared minus 3 root 2y equals negative 12. Now I'm gonna complete my square. So I'm gonna group this and this. Negative 2 divided by 2 would stay that way, square it to get my third term, and I'd get 2 over 4, or 1/2. So x squared minus root 2x plus 1/2. I also added on to this side. For the y, I have to take out the negative, so negative y squared plus 3 root 2y, leave that space. Takes that one. So then I have 3 root 2 divided by 2 squared, which is 9 times 2, or 18 over 4, which is 9/2. And add it here. So then I want to factor out my perfect squares. Square root the top and square root the bottom here to get this last term, which is actually this term. I get square root of 2 over 2. Put a minus between them. Minus y square root this. Square root of 9 is 3. Square root of 2 would be root 2. Rationalize it, and I get this one. Plus 3 root 2 over 2. Squared equals, put 24 over 2. This is 26. Plus 9, 37. Over 2. Oh, sorry, that's a negative. So negative 24 plus 1 would be negative 23. Negative 23 plus 9 would be negative 14. Over 2 is negative 7. Okay, so now I've got to divide everything by that negative 7, which is going to switch my order. So x minus root 2 over 2 squared over negative 7 plus y plus 3 root 2 over 2 squared over 7 equals 1. So this is now a hyperbola. I'm going to add my prime back in. 3 root 2 over 2 squared over 7 minus x minus root 2 over 2 squared over 7 equals 1. So I know it's a hyperbola. I know my center is root 2 over 2 and negative 3 root 2 over 2. I know my a squared, which is first, is 7. So a is the square root of 7, which is in between square root 4 and square root 9. We're going to say it's a little bit closer to 3, so maybe like 2.8. B is also 7, or b squared is also 7, which means b is also approximately 2.8. So now when I go to graph this, I have to remember that I have to rotate my axis, and we said theta at the very beginning, all the way at the top here. Theta was pi over 4. So I have to rotate my axis about halfway through, which is about there. That's my new x prime axis. My center is root 2 over 2, which is like 1.4 over 2, or 0.7. And then 3 root 2, 3 times 1.4, 4.2 over 2, which is 2.1, negative 2.1. So I start there. I'm going to go to a little bit less than 1, a little bit more than negative 2.1. That's my center. And then because the the y squared is first this time, I know that this is a vertical hyperbola. So I'm going to count from that center up and down my A to 1, 2, 3. So a little bit less than 3, 1, 2, 3, a little bit less than 3. And the same thing out the other way, because this is also, B is 2.8. 1, 2, 1, 2. Make yourself your little square. Draw your asymptotes through that square. And then we said this is vertical, so it's going off of these 2 points as close to, without touching that blue line as possible. So not the prettiest hyperbola, but you get the point. All right. So I mentioned it in class, but this is obviously a complete the square problem dealing with the rotation of conics. We're going to do one more. So this time A is 13, B is 6 root 3, C is 7. So A minus C over B gives me 6 over 6 root 3, which is 1 over root 3. So the cotangent of 2 theta should equal 1 over root 3, which means the tangent of 2 theta would equal root 3. So we know this is happening at pi over 3, so 2 theta equals pi over 3, and theta is pi over 6. There's my first checkpoint. X equals the x prime times the cosine at pi over 6 minus y prime times the sine at pi over 6. Y equals x times the sine of pi over 6 plus y prime times the cosine at pi over 6. Pi over 6 has the point of root 3 over 2 and 1/2. So if I take those and plug that in, I get root 3 x prime minus y prime all over 2. That's my x. And my y is x prime plus root 3 y prime all over 2. Now I take them and plug them back into my initial equation. So 13 times x squared. I'm going to drop the primes, but make sure I add them back in at the end. Plus 6 root 3 x y plus 7y squared I'm going to bump the 16 to the other side. So I'm going to start by squaring the first perfect or squared binomial. I can use that shortcut. So 13 goes on the outside. Square the first term, which is 3x squared. Square the last term, which is y squared. 2 times the product of these, which would be negative 2 root 3xy. And the square of 2, which is 4. Then I go to the next one. So plus 6 root 3. This time I'm foiling out my numerators. So root 3x squared plus 3xy minus xy minus root 3y squared all over 4. And this becomes 2xy. Plus 7, and shortcut, square the first one. 2 times the product of the 2 terms and square the last one. All over 4. Now I would multiply everything by 4 to get rid of those fractions. So it's gone, 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 and this becomes 64. Now I'm going to distribute the first term onto each of the ones remaining. So this 13 times 3 is 39x squared minus 26 root 3xy plus 13y squared. Distribute the 6 root 3. So 6 root 3 times root 3 would be 6 times 3 or 18x squared plus 18 root 3, or sorry, not 18 because I simplified the 6 gets multiplied times the 2. So 12 root 3xy minus 6 root 3 times, this is the last term, root 3, which is 18 y squared. And then the last one, which is distributing the 7. So plus 7x squared plus 14 root 3xy plus 21y squared equals 64. All right, so now we're here. We want to look for our xy terms. So I've got negative 26 root 3 plus 12 root 3, which is negative 14 root 3, and then a positive 14 root 3, which means I cancel these out, which is exactly what we wanted to happen. Then group together the x squared, so 39x squared plus 18x squared, that's 57x squared plus 7, which is 64x squared, and then do the same thing with the y's. 13 minus 18 is negative 5, plus 21 is positive 16y squared equals 64. Get it into standard form, dividing everything by 64, and I'm going to add the primes back in. So I get x prime squared over 1 plus y prime squared over 4 equals 1. So this is an ellipse. Center is at 0, 0. It's vertical because the larger number, which is my a, is underneath the y. So a is 2, b squared is 1, b is 1. So now I'm going to draw my initial coordinate grid, and then my axis, my rotation all the way up at the top there, that theta was pi over 6. So I'm going to come up to pi over 6. Make that my y, my x prime axis, my y prime. My center's at 0, 0. This is vertical, so I'm counting up 2, down 2, right 1, left 1. And there's my ellipse on the rotated axis.